All right, we are on 6.5, solving exponential equations. So we've looked at how to solve lots of different types of equations. We've looked at how to solve linear equations, absolute value equations. Today we're looking at how to solve exponential equations. So an exponential equation is an equation where your variable, so your x, is the exponent. So if you have an exponent where the exponent is 3 or 4, that's not an exponential equation because that's something you can actually simplify. An exponential equation is when you have your variable, your x, actually as your exponent. So, how do we solve them? If they have the same base and they're equal to each other, so these both have a base of 2, then that means that their exponents have to be equal to each other. So if we can get it so they have the same base, then all we have to do is set the exponents equal to each other, and then we're able to solve it. So let's take a look at some examples. So I have 3 to the 4x power is equal to 3 to the 12th power. They have the same base. If their bases are equal to each other, then that means their exponents have to be equal to each other. So I can just write an equation where the exponents are equal to each other. So I have 4x is equal to 12, which means when I solve it, I get x is equal to 3. So in the next one, they have the same base. Again, if they have the same base, you can set the exponents equal to each other. So I have x plus 5 is equal to 20. If I solve this equation, then I get x is 15. Try number 3. Okay, so the bases are the same. So I set the exponents equal to each other. So I have 4x minus 5 is equal to 2x. I need to get all my x's on one side, so I'll subtract my 4x over. So I have negative 5 is equal to negative 2x. When I divide both sides by negative 2, then I get x as a positive 5 over 2. Okay, but when we look at the next one, they don't have the same base. If they don't have the same base, I can't use this rule until I have the same base. So 256, I can actually rewrite 256 as 4 to the 4th power. And now they have the same base. They both have a base of 4, so I can set the exponents equal to each other. So 7 minus x is equal to my 4. If I subtract my 7 over, I get negative x is equal to negative 3, and when I divide both sides by my negative 1, I get x is equal to 3. On number 11, they don't have the same base, so I need to try to find a way to write them so that they have the same base. So see if you can find some base with an exponent that 64 and 512 can both be broken up into. So both of them can be broken up into 8 to some power. 64 can be broken down into 8 to the 2nd power, and 512 can be broken down into 8 to the 3rd power. But I can't just say 2 is equal to 3. That's not the problem. There was already an exponent of x plus 1 on the left-hand side. So I actually have to multiply my exponent that I created by the exponent that's there. And this one already had an exponent of x. So I rewrote it, and then I kept it times whatever the exponent was there originally. So I'm going to use the distributive property on the left-hand side. So 2 times x is 2x, and 2 times 1 is 2. So I distributed my new exponent times the exponent that was already there. And then 3 times x is 3x. If I subtract my 2x from both sides, then I get 2 is equal to x, and I can solve it. So your goal is to try to get it so they have the same base. Once they have the same base, then you can just set the exponents equal to each other. So try number 12. Okay, so I can rewrite 36 as 6 to the 2nd power, and it's still times my exponent of 2x plus 1. And on the other side, it's still equal to 6 to the 2x. So I was able to get it so they both have a base of 6, so now I can set the exponents equal to each other. So I have 2x is equal to distributive property on the other side, so 2 times 2x is 4x, and 2 times 1 is 2. Now I need all my x's on one side, so I'm going to subtract my 4x over. So I have a negative 2x is equal to 2. When I divide both sides by a negative 2, I get x is a negative 1. Okay, on number 13, now we have a fraction. So to get rid of that fraction, we're going to use our rule about negative exponents. So 1 over 7 is technically 1 over 7 to the 1st power. If I want to flip it, so I have 7, instead of 1 over 7, I want to take the reciprocal of it, then I need to make the exponent negative. So it would be a negative 1 times x, or just a negative x. And then it's equal to 2,401. I need to rewrite as 7 to 1, some power. So do 7 to the second power, 7 to the third power, 7 to the fourth power until you find the one that works. So 7 to the fourth power is actually equal to 2,401. So now they have the same base. I'm going to set the exponents equal to each other, divide by my -1, and I get x is -4. Try number 14 and number 15 and then check back and see how you did. Okay, so on number 14, I'm going to rewrite 512 as 1 over 512 can be rewritten as 512 to the -first power. And then I need it so it has the same base. So 2 to what power gives me 512? Well, 2 to the 9th power. So this would actually become 2 to the -9th power, equal to 2 to the 3x minus 1 power. So now they have the same base, and I can set the exponents equal to each other. So I have -9 is equal to 3x minus 1. If I add the 1 over, then I get -8 is equal to 3x. And when I divide by 3, then I get x is -8/3. So for all of you people who think that, oh, I never have to show my work, I can do all this math in my head, I don't think that's going to be the case when you're solving these problems. Look at the complicated math that we're doing. Don't try to solve these problems in your head. Make sure you're writing down your steps, taking your time so you're less likely to make those mistakes as you're making your calculations. Okay, on number 15, 25 and 1 over 625. Well, 625, I need to rewrite as 625 to the -first power. But if I'm trying to break it down so it has the same base as 25, 25 to the second power is already too big. So I know I'm actually going to have to break down both sides. So 25, I actually have to break down as 5 to the second power. Oops, that's a 5. My pen didn't carry well. 5 to the second power, and then it's still times 2 minus 2x. And then 625 is the same thing as 5 to the 4th power, which means this is the same thing as 5 to the -4th power, and then still times my x plus 1. So I got rid of my fraction, and I got them so they have the same base, and now I'll set my exponents equal to each other. So I'll use the distributive property. So 2 times 2x is, 2 times 2 is 4, minus, and then 2 times 2x is 4x. And then that's equal to, my exponents on the other side, distributive property, would be a -4x minus 4. So, let's see. Oh, wait, hold on. 5 to the second power. I made a mistake. 5 to the second power. Hold on. 5 to the second power is 25, and then I multiplied it through 4. Okay, never mind. We're good. Okay, so I need to add my 4x to both sides. And when I do that, I get 4 is equal to -4. What does that mean? That's not a true statement. 4 is never equal to -4. So if you get something that does not work out, your answer is no solution. Okay. So when we get to number 16, we need to be able to write them so that they have the same base. But notice, I've got a -9 and I've got a +3. I'm not going to be able to get these to have the same base because one's a negative and one's a positive. So if that's the case, your only option is to use a graphing calculator. So I'm going to tell you right now, if the instructions say use a graphing calculator, you're going to use a graphing calculator. If it doesn't say that, you can't use a graphing calculator, okay? So make sure that you are showing your work to show and prove that, yes, you can do this without a graphing calculator on the ones like up through number 15. So graphing calculator, you're actually going to go to Desmos. Oops. And I should delete what I have here so that you can't see it. Okay. So on Desmos, it looks like this. You're just going to type in your two equations. So my first equation was 3, or the first side of it was 3 to the x plus 3 power. So I'm just going to write y equals, and then 3, and then I'm going to do an exponent. So I'm going to use the little caret key to make it the exponent, and then it's going to be x, and then, oops, I need it to be in the exponent still, so plus, let's see, I guess I need parentheses around x plus 3, and then it'll let me keep it all in there. Okay, so there's what that exponential graph looks like. You can see that it's this graph right here. It's getting closer and closer to 0, never crosses it, and it's going up exponentially fast. Okay, So then my next one was just -9. So I'm going to type y equals -9 for my second one. When I look at this graph, this one's getting closer and closer to 0, but never crossing it. And this is all the way down here at -9. When is this line going to cross it? Because we know where the two graphs cross is going to be my solution. Well, if this never is going to cross 0, there's no way it's going to come down here. So the answer to this one is going to be no solution. Okay, so on number 17, 1/4 is the same thing as 4 to the negative first power. So I could rewrite at 4 to the negative first power. That's also the same thing as 2 to the negative second power. But 2 to no power and 4 to no power will give me 18. There's no way that I can rewrite that. So I'm going to go to my graphing calculator instead. So I'm going to erase the ones that I originally did, and I'm going to type in my new one. So I always type in y equals, and then the one side of the equation. So this was 1/4. And then, 1/4. I don't need that parenthesis. Okay, and then my exponent, so I'm going to use my caret to go up to my exponent. My exponent on this one was a negative x minus 1. Then my other side was just 18, so y equals 18. Okay, so now I can zoom in a little bit onto my graph. I need to know where they intersect. They intersect at this point right here. So what am I looking for? Am I looking for the x-coordinate or the y-coordinate? Well, the original problem didn't have any y's in it. I just added that so that I was able to graph it. So I'm just looking for my x value. So my x value is this number right here, the 1.085. So that's what I'm going to get, 1.085. So I'm able to graph it and find where the two sides of it intersect. And we would do the same thing on number 18. Okay, let's look at number 22. So it says you deposit $1,000 in a savings account that earns 5% interest. We want to talk about it being compounded yearly. So yearly is once a year. So exponential equation, we know it's going to be our compound interest. So that's our equation, y is equal to our initial deposit times 1 plus our interest rate as a decimal, so 0.05, divided by how many times it's compounded per year, which in this case is just 1. And then it's times how many times it's compounded per year and times the number of years. So that's my equation. I can simplify this to just y is equal to 1,000 times 1.05 to the t power. Okay. So it says write an exponential equation now to determine when the balance of the account will be 1,500. So it's wanting me to replace y with 1,500. So I have 1,500 is equal to 1,000 times the 1.05 to the t power. I need to know t. I want to know the time. So I'm going to go to my Desmos and I'm going to type it in. So one side of my equation was y equals 1,500. The other side of my equation is y equals 1,000 and then times 1.05 and the exponent of, it was an exponent of t, but exponent of x is how we're actually going to graph it. And then we're going to come over to our graph and we're going to have to zoom way out because we're talking about all the way up here at 1,500 is where my y equals line. So now let's zoom into this point. All right, so where do they intersect? Well, they intersect at 8.31, 1,500, which means what's our answer? Our answer is at about 8.31 years. So 8.31 years, and that's approximate, is when they are going to have a balance of $1,500. So in a little over 8 years, they will have made $500, but just by having their money in that account. Okay, take a second and write your summary, mark anything that you have questions on, and then we'll be ready to talk about tomorrow in class.